Hello everyone. Have you ever wondered how electricity and magnetism are connected? Well, for a long time, they were considered separate forces. But as early as the 1830s, scientists like Oersted and Ampere started asking, could they be related? They found out something incredible. When electric charges move, they actually produce magnetic fields. This discovery set the stage for the idea that electricity and magnetism are interlinked. For example, when an electric current flows, it can deflect a magnetic compass needle placed nearby. This is just one of the wonders of electromagnetism. Now, let's talk about two scientists, Michael Faraday and Joseph Henry, who made groundbreaking contributions to this concept in the 1830s. Faraday and Henry independently discovered that changing magnetic fields can induce electric currents. Imagine you have a coil of wire and a magnet. If the magnet moves in and out of the coil, it generates an electric current in that wire. That's electromagnetic induction in action. They proved that electric currents can be created in closed coils when exposed to changing magnetic fields. This discovery was a pivotal moment in physics, and it led to the development of technologies like electric motors and generators. So, what exactly is electromagnetic induction? Simply put, it's the process by which a changing magnetic field creates an electric current in a conductor. Faraday's law captures this phenomenon perfectly. Let's break it down. The induced electromotive force, or EMF, is given by the formula E equals minus d phi divided by dt here. E is the induced EMF and phi is the magnetic flux. Magnetic flux is the product of the magnetic field, the area through which it passes, and the angle between the field and the surface. When the magnetic flux changes, an EMF is generated. The negative sign in the formula comes from Lenz's law, which tells us that the induced current will oppose the change in magnetic flux. It's like a reflex in nature. Now, here's a fun fact about Faraday. When he first demonstrated this discovery, people were skeptical. When asked, "What's the use of this?" Faraday famously replied, "What's the use of a newborn baby?" He realized that this discovery was just the beginning, and its applications would unfold in ways no one could have predicted. And he was right. Today, electromagnetic induction powers nearly every electric generator, transformer, and motor we use. It's everywhere, from your smartphone to power plants. Electromagnetic induction is not just a theory, it's the backbone of much of our modern technology. Think about electric generators. They rely on the principle of induction to convert mechanical energy into electrical energy. Induction is also at the heart of transformers, which change the voltage in power lines to make electricity travel over long distances. In fact, without electromagnetic induction, we wouldn't have the electrical grid we depend on every day. It's what makes our world go round, quite literally. Let's take a look at a practical example to make sure we understand this concept. Imagine you have a coil of 50 turns with an area of 0.02 square meters and a magnetic field that changes from 0.1 Tesla to 0.5 Tesla over 0.1 seconds. The induced EMF can be found using Faraday's law. First, we calculate the change in magnetic flux. Delta phi equals A times delta B, where A is the area and delta B is the change in the magnetic field. So, delta phi equals 0.02 times open bracket 0.5 minus 0.1 close bracket equals 0.008 Weber. Now, applying the formula for induced EMF, E equals minus N times delta phi divided by delta T, where N is the number of turns, delta phi is the change in flux, and delta T is the time interval. Substituting the values, E equals minus 50 times 0.008 divided by 0.1 equals minus 4.0 volts. So, the induced EMF is 4.0 volts. Remember, the negative sign just indicates the direction of the current. It opposes the change in magnetic flux as per Lenz's law. This is a simple but powerful way to generate electricity. To wrap things up, let's revisit what we've learned. Electricity and magnetism are not separate entities, they are two sides of the same coin. Faraday and Henry's discovery of electromagnetic induction changed the course of physics and technology forever. The key takeaway here is Faraday's law: a changing magnetic flux creates an induced EMF, which drives current in a conductor. This principle powers everything from your home appliances to massive power grids. So, next time you flip a switch or plug in your phone, you'll have Faraday to thank for the electricity running through your devices.